Hello students, so we are starting a new chapter for class 12, that is moving charges and magnetism, and a brief introduction about it. So we know the reason around a magnet where a magnetic needle experiences the torque and rests in a definite direction is called the magnetic field. So see, these are the reasons around a magnet, and the magnetic field experiences a torque around it, and the needle deflects in the direction of the magnetic field. So these are the needles, they are deflected in the direction of the lines of force. These are the lines of force of the magnet. The field emanates from the north pole, and straight away in space it goes to the south pole, and inside the magnet it passes the south pole and comes to the north pole again, like this way. And these lines of force, they never intersect each other. So when you suspend a magnetic needle, it always rests in the north-south direction. So if we suspend a magnetic needle, it always points towards the north and the south direction. If we suspend this magnetic needle, it will always point in this north and south direction. Suppose this is north and this is the south. North pole of the needle points towards the north and the south pole points towards the south. So these, if this is the earth, so this is north pole of the needle, we will get the north pole of the needle, and this is the south pole of the earth. So now Oersted experiment, we learn about this Oersted experiment. During a lecture in 1820, the Danish physicist Hans Christian Oersted, he noticed that a current in a straight wire caused a noticeable deflection in a necessary magnetic field, in a necessary magnetic compass needle. Now let us study this experiment. AB is a conductor. Now three positions are given. They are connected with a battery. This is the switch. In the first case, the switch is open. That means no current is flowing through the circuit. On both sides of the conductor AB, the wire is connected. In the second case, the switch is connected, means switch is in on position. That means this path is the closed path. This path is the closed path, and current is flowing through the path, and current is flowing through the battery and the conductor. In the next position, the polarity of the battery is reversed. We have changed the polarity of the battery. B is connected now with the positive, A is connected in the negative. In case 2, B was connected with the negative and A was connected with the positive. So third case, the polarity is reversed. To reverse the direction of the current, so when it is open circuit, we have seen there is no deflection of this magnet, it's straight. Now in the second case, when switch is on, this north pole has moved towards the conductor, is directed towards the conductor. And in third case, you have seen that this north pole, it has moved far away. It has moved far away, it is deflected by the conductor. Now this experiment shows that the magnetic field is produced due to electric current. Since electric current is charge in motion, it is a charge in motion, constitutes electric current. If another moving charge is brought into the magnetic field so produced, the field exerts a magnetic force on the moving charge. So if a moving charge, if suppose this is a conductor, current is flowing, so within this conductor the charge is moving. Within this conductor there is charge, and that's why it constitutes an electric current I. Now this I produces a field around the conductor. This produces a field around the conductor. And if a charge is brought near this field, within the field of this conductor, it will experience a force due to this magnetic field. Now we shall study further about these current carrying conductors in this chapter. Now let us study a brief history about electricity and magnetism and how are they related. Now both electricity and magnetism, they were known for more than 2000 years. It's for more than 2000 years. Now Hans Christian Ørsted in 1820, he showed that current in a straight conductor caused a noticeable deflection in a nearby magnetic compass needle. Okay, so suppose the current is flowing here, and see the deflection. The current emerges out of the plane of the paper. The current emerges out of the plane of the paper. When it enters over the top of the paper, it is so this is the tangent. This is the tangent and of the circle. There is a compass needle. So in this case, we ignored the field of the Earth's magnetic field. So Earth's magnetic field is ignored, and the current is sufficiently large. These are the two things, that Earth's magnetic field is ignored and the current is sufficiently large. Now on reversing the direction of current, reverses the orientation of the needle. See, here current is flowing. In this case, the current is flowing from the down of the paper, from the bottom of the paper. That means from the other side, from under your table in which you are studying, the current is entering through it. So this is the case where current is entering from under a table. If you put your framings under right hand, then you will be able to see the direction of the magnetic field. Okay, and in the second figure, current is entering from current is entering from the top of the table. Current moves into the plane of the paper. Thus reversing the direction of the current reverses the orientation of the needle. Now how much the needle will be deflected, it depends on the strength of the current. What is the strength of the current? The deflection varies as deflection between the distance between the wire and the needle, means how far is the needle from the current carrying conductor. So if the distance is less, the deflection will be more. If the distance is more, the deflection will be less. Now next diagram we will show arrangement of iron fillings around the wire. Now if you insert a wire in a plain piece of paper carrying a current and sprinkle some iron fillings over it, you will see the alignment of the iron fillings in the concentric circles. Now what does Oersted conclude? That moving charges or current produced in a magnetic field in the surrounding space. It is the moving charges or the current which produces a magnetic field in the surrounding space. Means the space by which it is surrounded by. Okay. Now James Maxwell in 1864 he unified the laws obeyed by electricity and magnetism, and he realized that light is an electromagnetic wave. Next came the Hertz. He discovered the radio waves. J.C. Bose and G. Marconi, they produced radio waves by the end of 19th century. Now these radio waves were discovered by Hertz, not produced by Hertz. Remind it. You must remember it. And it was produced by J. Bose and G. Marconi. In the 20th century onward, there is remarkable progress in the invention of devices for production, amplification, transmission, detection of electromagnetic waves. The remarkable improvement in this field.